Hello guys, in this video we are going to talk about drift velocity, which is often a very misunderstood term, and we will talk about this in great detail. Let's go. Suppose there is a body, any random body, in which we apply an external electric field. Okay. An external electric field we apply here, and its, let's say, value is E, and we're assuming for our convenience that this electric field is constant. Why we are assuming it constant? We are assuming it constant so that since it's constant, so its magnitude will not vary in the body at different positions, so the force on every charged particle will be same. Now let's go. We know that in a body, in a conductor, or in any body, sort of speak, every particles are in constant random motion. Let's say there are particle number 1, particle number 2, particle number 3, and all that. So these are electrons who are in constant random motion, which we call conduction electrons, and so there are n particles. This body was, let's say, doing random motion, but as you applied an external electric field, a force will be applied in this particular body, and that force will be QE. This force will be QE, Q into E. Since there will be force, so there will be an external there will be an acceleration too, and that would be force divided by its mass. Now let's say after applying electric field, its velocity will change because a new force is being applied on every particle, and let's say we are trying to find out the final velocities. So we know from equations of kinematics that, let's say, the final velocity of first particle is initial velocity of first particle plus at, and a is QE by m into t1. Okay, again we are here finding v2, and this is initial velocity of second particle plus acceleration of second particle upon t into t. So we will find this for nth particle, and final velocity of nth particle equals to initial velocity of nth particle plus acceleration, that is QE by m into tn. Now what we are doing is we are adding these all. So here we are doing it, we are adding it. So from I equals to 1 to n, and this is Vi equals to summation of I equals to 1 to n, and this is Ui, and this is, let's say, let me write it more clear, and this is Ui plus QE by m will be taken common from all because it is a constant term, and it appears in every term. So QE by m, and this is summation of Ti, and I equals to 1 to n. Okay, we are dividing this equation. Now this is the final state of this is the final velocity of this body, of every particle, and from our common sense we can say that this was initial velocity of every particle before electric field was applied, and since it is initial velocity, so it is actually random motion, and sum of all random motion of a body is 0. So this whole thing becomes 0, and now this equation simplifies as, here we go, sigma I equals to 1 to n, Vi equals to QE by m into t into sigma Ti I equals to 1 to n. That is the thing. Now this is for every individual particle. If we divide it by number of particles, we'll get an average. So, and this term is actually what we call as drift velocity, and this becomes QE by m, and here we define a new term that is called tau, and this is effective time of collision between two particles. This is effective time of collision between two particles. So this is equation, this is the way to derive drift velocity, and we can see its relation. It is directly proportional to electric field and directly proportional to tau. So these are very important thing we can find out from drift velocity.